Hi guys, this is Khushbu and welcome to Algorithms Made Easy. In this video, we'll see the question Course Schedule Part 3. We already have the videos for Part 1 and Part 2 that you can go and see, and today we'll see the Part 3 of that question. There are n different online courses numbered from 1 to n. You are given an array courses where course of I has the data for duration and the last day. This indicates that ith course should be taken continuously for the duration days and must finish before or on the last day that is given. You will start on the first day and you cannot take 2 or more courses simultaneously. Return the maximum number of courses that you can take. So here's the example given. You have 4 courses that are given and your output is 3, that you can take only 3 courses within the time frame that is given to you. So the first course has a duration of 100 days and should be completed on or before the 200th day. Course 2 has a duration of 200 days and should be completed before 1300th day. Similarly with course 3 and course 4. So you will take the first course and it would be costing you 100 days, so you will be finishing it on the 100th day. Second, you can take up the third course or even the second course. If you take the third course, your course would get completed on this 100 plus 1000, that is 1100th day. Thirdly, you take the second course and that would cost you 200 days, so you will be finishing it on 1300th day, which falls exactly on the last day given in the second course. If after 1300th day you start the course 4, you will go beyond 3200th day and that would be exceeding the close date. So you cannot take up this course and you will end up only taking 3 courses from the 4 courses given. So that's why the answer is 3. For the example 2, you are given 1 course which has duration of day 1 and you need to complete it on or before the second day, and so you can complete that 1 course. In the third example, you are given 2 courses, and if you see over here, the duration of this course is 3 days and you need to complete it before the second day. This course has a duration of 4 days and it need to be completed before the third day, and so there is no possibility that you can complete either of the course, and so the answer over here is 0. In the constraints we are given the length of the course that can be, and the value can range up to 1 to 10 raised to 4 in duration and last day. So now let's go ahead and see how we can solve this question. Suppose I have this input given with me. What I need to find is the maximum number of courses that I can finish given the duration of a particular course and the end time or the last day on which you can complete that course. So what is the total time frame that I have? For that, I can simply sort the input on the end time, and after sorting it, the input looks like this. So I have this in the ascending order of the last day on which I need to complete the courses. If I am getting the same last day, in that case over here I have sorted based on the duration of the course. And so I now have the time frame that in 20 units of time I need to see how many courses I can complete. After this, I can start iterating and use a greedy approach to find the number of courses that I can complete. In the greedy approach, for the current iteration, you check whether you can include that particular data in your result or not. If you can, you include it. If you can't, you will check whether you can exclude some data from your result set, and instead of that, if you can include this particular data. So now what's the intuition behind this approach? Intuition behind this is that for any iteration, I'll see whether I can complete that course in the given time frame or not. If yes, I can consider that course, and if not, then I can swap that with the biggest duration course that I have already taken up. And one thing that we need to note over here is that the swaps must reduce the time we have taken till now. We should not be exceeding the time we were taking previously before swapping it with the current course. So that's the intuition behind this question, that we are going to check whether we can take up this course or not. If we cannot take up this course, is there any way we can exclude some other course and take this course, which would optimize our solution? Now that we know this, let's see how this particular approach will work for this example. I have taken this example over here, and this x-axis is marking the time frame and the y-axis will have my task. So my first task is of duration 9 and I need to complete it before the 10th day. So I can take up this task and so I put it in my data structure and I update the current time, that is the time that I have taken until now to complete all the tasks or all the course that I have considered. Next we go to 3 and 12. So this has the duration of 3 and needs to be completed before 12th day, and over here you can see that it is getting completed on the 12th day and that is fine. So we go ahead, include this course and update the time. Third course is of duration 7 and we need to complete it before 17th day. But if you include this task, you will be ending it on the 19th day, which cannot be done. So at this point of time, you need to check whether you can take up this course and remove some other course from the courses that you have chosen. So I'll be comparing it with the biggest course that I have, and that is this. So I'll be replacing this one with 9. And so now my time becomes 10, wherein I'll be completing 2 tasks. For the next one, you can see that this course has a duration of 4 days and need to be completed on or before 18th day. And that is possible because we are completing this in 14 days. So you take it up and move ahead. Now you have one with 10 days duration and you need to complete it on or before the 19th day, which is not possible. It's going beyond my 19th day, as you can see over here. So I can check whether I can swap it with some other course that I was taking up. The biggest course that I had was of 7 days, and considering that course, I was able to complete the 3 courses in 14 days. But if I consider the newer one or the current course, I'll be able to complete all the courses, that is all this 1, 2 and 3 courses in 17 days. So is this swap helpful in order to optimize your answer? What do you think? Definitely not, because the duration that we are trying to insert would be larger than the one that we are going to remove. And so it would not be optimizing our solution. And that's the reason we'll do nothing but move further. Now this course has a duration of 5 days and needs to be completed on or before 20th day, and that is happening. So we can take up this course and we move ahead. Again, this course has 10 days duration and need to be completed before the 20th day. Can you do it? For that, we need to check whether we can swap it with some other course. And over here also, the biggest course that I was having was of 7 days and I need to see whether I can take up this 10-day course instead of 7-day course. But if you do that, your timelines would be shifted and that would affect the end dates of your other tasks. And those can go out of the bounds or out of the schedule that is given to you. And so you cannot take up this. So we just ignore this one and move ahead. Since this was the last one, you can say that we can complete 4 courses in the time frame of 19 days. And so 4 is our answer for this particular input. Now let's recap what were the steps we need to follow. First is sorting the array. So we will be sorting the array based on the last day. Then we will be taking a data structure wherein we can easily get the maximum from it at any given point of time. And for that kind of a data structure, priority queue or max heap is the best one. And so we will be taking that. After you are done with your priority queue initialization and sorting the array, you will iterate over the input and try to minimize the end time while maximizing the courses that you can take up. Finally, return the number of courses completed. So this courses completed would be equal to the size of your priority queue at the end, because all the courses that you are going to take up are stored in your priority queue at any given point of time. So let's just go and code it out and see what all conditions we are going to apply. The first thing we need to do over here is sort this courses array based on the last day, and if the last day is same, we can try to sort it based on the duration of the course, but that's optional. I'll do it. So this would sort your array based on the duration if my last day is equal or else it would be sorting my array based on the last day. Second thing that I'm going to do is take the priority queue, and this is going to be a max heap, so I need to sort this in descending order, and this would do the work. Third thing that we need is time, and this time would denote the time that I have taken to complete all the courses that I have considered till now. After we are done with this, we need to iterate over our courses. And in here, we need to first check if we can consider current course. That is, if the duration of this course is less than or equal to the last day on which I need to complete this course. Because if that is not the case, there is no way possible I can choose this course. So that means my duration is lesser than the end day. And if that is the case, now I need to check whether I can consider this course or I need to swap it with some other course in my priority queue that I have already considered. So if the current course can be completed within the last day given, that is, if duration plus time I have is less than or equal to the last day that is there, that means I can complete this course. So I'll add it in my queue, and in my priority queue I am going to add the duration, because in the case of swapping I need to consider the duration of the course, and with this I'll also increase the time. Now what if this is not the case? That is, I cannot consider this course as is. So check if we can swap. And that could happen only if the element that I'm going to pop or remove from the priority queue has a time greater than the one that I'm going to insert. And so if that is the condition, I need to swap it. So for that, I need to decrease the time by the one that I have popped, and then add the time of the current course and add the current course into priority queue. So that's it. At the end, I'll have all the courses that I'm going to consider in my priority queue, and I can just return its length or size, and those would be the number of courses that I'll be considering. And this would be a priority queue. Let's run this, and it's giving a perfect result. And let's run this for the test case that we saw in our example, and that's also running fine. Let's submit it. And this got submitted. The time complexity for this solution would be O of n log n, as we are going to sort the courses array, and the space complexity would be O of n, that is the length of the courses, because at any given point of time the maximum number of courses that can be present in my priority queue is all the courses, that I can take up all the courses. You can also reduce this code. Now you can shorten this code by reducing the conditions that you are using, and the shortened code version is also present on the GitHub link that we have in the description. You can go ahead and check it out. So that's it for this video, guys. I hope you liked the video, and I'll see you in another one. So till then, keep learning, keep coding.